Jai Hind students, welcome to this particular session. In this particular lecture, we will continue with the mathematical tools, and in the next few minutes, we will be discussing graph. Now before we start various types of graphs and the standard equations of various graphs, we need to understand the meaning of a graph. Now students, graph means a diagrammatic representation showing the variation of one physical quantity with respect to the other physical quantity. So basically a graph gives a pictorial representation of the variation of one quantity with respect to the other quantity, right? So that's graph for you, and graphical interpretation is very important. So for that, you need to know the standard equation of various graphs. In this session, we will discuss the standard equation of a straight line, how to get the slope, then the straight line having positive slope, having negative slope, having intercept on the positive y-axis, having intercept on the negative y-axis. Then obviously we will discuss parabola as well, symmetric parabola, asymmetric parabola, right? And then we will discuss also ellipse and then the standard equation of a circle. So let's start with straight line. Let's start with the standard equation of a straight line. The standard equation of a straight line is, students, it is y is equal to mx plus c. This is the standard equation of a straight line. X and y are the variables. M, this is known as the slope, and it is equal to tan theta, which in turn is equal to, we'll prove it, y2 minus y1 divided by x2 minus x1. So slope, it represents the tangent of the angle which the line makes with the horizontal, and it is given by y2 minus y1 divided by x2 minus x1. And students, the c, this represents the intercept on the y-axis. It represents the intercept on the y-axis, right? So any equation which is in this standard form, then if you plot a graph between those two quantities, it would always be a straight line. And here I must mention, between x and y, one is the independent variable and the other is the dependent variable. While plotting graph, we make use of certain convention. So as a convention, just make sure to represent the physical quantity which is an independent variable to be represented along the horizontal axis, that is along the x-axis. While the dependent variable, that should be represented along the vertical axis, that is along the y-axis. So this is the convention which we generally follow, right? So coming back to this, the degree of the equation is 1. So whenever the degree of an algebraic, the degree of a polynomial with two variables, right, is 1, then if you plot a graph between those two variables, it should always be a straight line. So degree of this equation is 1. That's the mandatory condition for a straight line, right? So let us discuss the slope. This is suppose the x-axis and this is y-axis. So this is the straight line. This is y is equal to mx plus c, right? This is the point where the straight line intersects on the y-axis. So this distance from the origin, it is c. So in this case, c is constant, which is the intercept on the y-axis, right? M stands for the slope, that we'll discuss. Suppose, let us consider this to be point P and let us consider this to be point Q. Let us consider the ordinate and abscissa at point P be x1, y1, while at point Q let it be x2, y2. Now what to do is, drop perpendiculars to the x-axis. So this distance, it is x1, and this distance, it is x2. So this distance would be x2 minus x1. It's pretty clear from the diagram, isn't it? Again, drop perpendicular from P and Q to the y-axis. So you'll get diagram like this. So this is basically this one. this is y1 and this is y2. So this distance, it will be y2, while this distance, it is y1. Right? So extend this line. Now consider this right angled triangle. Consider this right angled triangle. This is the right angled triangle I am talking about. Consider this right angled triangle. What about its base? It is x2 minus x1. What about its perpendicular? This is y2 and this one is y1. So this distance would naturally be y2 minus y1. Fine, students? And theta over here is this angle. This is theta. So theta is the angle which the straight line makes with the horizontal. Theta, students, is the angle which the straight line makes with the horizontal. Right? So tangent of this angle, that is slope. So slope is the tangent of the angle which the straight line makes with the horizontal. So now consider this right angle triangle and tangent theta, we are aware it's perpendicular divided by base. So what's the perpendicular? It is y2 minus y1, and what is the base? It is x2 minus x1. So that verifies the expression for the slope of a straight line. Right, students? So m denotes the slope which is equal to tan theta, which in turn is equal to y2 minus y1 divided by x2 minus x1. And remember, slope of a straight line is constant. Why it is constant? Because if you drop a horizontal over here, then this angle will be equal to this angle, the corresponding angles. So whether you find the slope between any 2 points on a given straight line, the slope of a straight line is always constant. The inclination of the line with respect to the horizontal for a straight line will always remain same. Right, students? So positive slope means like this, uphill. Negative slope means m is negative. So it means that it is the case of downhill. Uphill will represent positive slope, downhill will represent negative slope. We'll discuss all the feasible cases in the case of a straight line, right? So the standard equation of a straight line then is y is equal to mx plus c, where x and y are the variables, isn't it? X is the independent variable, y may be considered to be the dependent variable. M is the slope, which is given by tangent of angle theta, and c is the intercept on the y-axis. It can be positive, it can be negative. Accordingly, there may be various cases. So suppose this is the standard equation, right? Y equals to mx plus c. That's the standard equation. Now what to do is, let's consider case 1. Okay, this is x-axis, this is y-axis. Suppose this is the straight line. So here the straight line is passing through the origin. So here c is 0. So the standard equation of the straight line would be y equals to mx. Is it clear, students? M is the slope, and here c, that is the intercept of the y-axis, is 0. So in such a case, in case of y equals to mx, it would be a straight line passing through the origin. Right? Consider the case of Ohm's law. You must have studied in class 10. V is equal to IR, isn't it? R is resistance, which for a given physical condition of a conductor is constant. So V is directly proportional to I. So from Ohm's law, V is equal to IR, isn't it? So if V is represented along y-axis and current is represented along x-axis, then the graph between V and I would be a straight line showing the linear dependency of these two quantities, and it will be a straight line passing through the origin. It is satisfying this equation y equals to mx. So students, comparing these two, y equals to mx, right? Comparing these two, the slope of V and I graph will give us resistance. So that's the importance of VI graph. The slope here will give us resistance in this case. Clear, students? So straight line indicates that in this case with the increase or decrease in one physical quantity, the other physical quantity will also accordingly proportionately increase or decrease. So it shows the linear dependency between two physical quantities. Clear? So this is for y equals to mx. It's the standard equation of a straight line passing through the origin. We'll discuss some other cases as well. Let's consider case B. This I have stated. This is a straight line and having standard equation of y equals to mx plus c. It's having positive slope, so m is positive, and it is having some finite value of c. So this will be the intercept on the y-axis, right? Now let's discuss an example. Let's consider the first equation of motion. You are aware v equals to u plus at, or it may be written as v is equal to at plus u, right? So if you represent velocity along y-axis, time along x-axis, then the graph would be like this. It would be a straight line. Slope of this graph, please compare mx, coefficient of x is slope. Here x is represented by time, so the coefficient of time is acceleration. So slope of this graph will give us acceleration, right? And what about c? It is the intercept of the y-axis, which in this case is u. So this one, which is the intercept of the y-axis, it will give us the initial velocity. It will give us the initial velocity, which the body pauses at time t equals to 0. So, by using the first equation of motion, that is the case of an uniformly accelerated motion, if you plot graph between velocity and time, it should be a straight line inclined towards the time axis for positive acceleration, right? Slope of Vt graph will give us acceleration. Okay, let's consider third case. It can be like this as well. In this case, c is positive, but the slope is negative. It is downhill, slope is negative. So what's the standard equation of this? It will be minus mx plus c. Here slope is negative, right? So it will represent, if you plot v over here and t along x-axis and velocity along y-axis, then it will represent the case of uniformly decelerated or uniformly retarded motion, where the slope of this graph, which in that case will be acceleration, it will be negative, right? So for this equation, this is the type of graph which we will obtain. Then there are some other cases as well. In case it is like this. So this line is having positive slope uphill, but intercept on the y-axis is negative. This one is c, right? So here the standard equation will be y equals to mx minus c. This also represents straight line, right? C can be either positive, negative, or even it can be 0. This slope, it can be either positive or it can be negative. Okay, another case. Let's consider this case as well. This is y-axis and this is x-axis, suppose. Let's consider the graph to be like this. So this is c, and here theta is 0. The angle which the straight line is making with the horizontal is 0. Means over here slope is 0. That is m is 0. So what's the standard equation of it? Putting m as 0 over here, we will get y is equal to c. This is c. So in this case, it will be a line which is parallel to the x-axis. So these all are the various possibilities in the case of a straight line. So students, whenever the degree of a given equation is 1, then if you graphically represent the two independent variables, one is the independent and the other dependent variable, the variation is plotted diagrammatically, then we should get a straight line. So this is the standard equation of a straight line, and these are the various possibilities which we can have. So we have discussed straight line, its standard equation, and then we have also discussed the slope of a straight line. Now what we do is, we'll consider parabola, or we'll consider symmetric and asymmetric parabola. Okay, case of a parabola. Now the standard equation of a symmetric parabola. Standard equation of a symmetric parabola is y square is equal to 4ax. This is the standard equation of a symmetric parabola. Here 4a is constant. This is constant. X and y are the variable. So what is the degree of this equation? It is 2. Whenever the degree of an equation is 1, then the graph would always be a straight line. If the degree of the equation is 2, then the graph would always be a parabola, either a symmetric parabola or an asymmetric parabola. So let's first discuss symmetric parabola, right? For this, the nature of the graph would be like this. This is the x-axis, this is y-axis. Now make use of your common sense. For two same but one positive and the other negative value of y will have the same value of x, isn't it? Suppose y is equal to plus minus 1. X will have the same value. For y is equal to plus minus 2, x will have the same value. For y equals to plus minus 3, x will have the same value. So therefore, for two values of y, x will have the same value. X will have the same value for two values of y. So the equation will be like this. This is the graph. This part is the mirror image of this part. So that is the reason why it is known as a symmetric parabola. Right? For two different values of y, I'll show you with the help of the diagram. Suppose this is y is equal to plus a and this is y is equal to minus a. For plus minus a value of y, x will have the same value. X will have the same value. So that's symmetric parabola. It will be like this, passing through the origin and like this, as shown in the figure. Right? So, second case. In case it is y square is equal to minus 4ax, then the graph will get changed. It will be like this. It's okay? This is the standard equation. Y square is equal to minus 4x for this particular graph. Right? Then, third. Suppose it's x equals to 4ay. Again, x and y are variable. 4a is constant. The degree of the equation is 2. So it must be a parabola. Here, for two positive or negative value of x, say having same magnitude, y will have a single particular value, isn't it? For x equals to plus a and x equals to minus a, y will have a unique value. So the graph obtained in this case would be somewhat like this. This is x-axis, this is y-axis. Look, for two different values of x, y will have a same value. So the graph would be like this. So for x square equals to 4ay, the graph would be in this particular manner, as shown in the, as drawn in the board, right? Fourth, if it is x square is equal to minus 4ay. So in this case, the graph would be inverted. This is negative y-axis, so it will be like this. So I hope it's clear. These are the various possibilities in the case of a symmetric parabola, right? The degree of the equation should be 2. So that's the standard equation. Let's consider some examples in physics where we'll be requiring to plot such graphs, right? Students, you all are aware of the time period of a simple pendulum. You must have studied in class 9, isn't it? In the chapter of periodic and vibratory motion. So, simple pendulum is basically an arrangement comprising of a heavy metallic bob suspended to a rigid support with the help of a string or a thread. Now, when it is disturbed from its mean position release, it will start executing vibratory motion, right? The time period is given by time period of a simple pendulum is given by t equals 2 pi square root of L by G. G is the acceleration due to gravity, right? It is constant for a given place. At a given place, it is constant. So if you want to plot a graph between t and L, so what should be the nature of the graph? Let's see. So t square, it would be equal to squaring both sides. We get like this. So it can be written as t square is equal to 4 pi square by G. This is constant L. Now look, it's very, very important. There are two cases. First, if you plot graph between t square and length, if you plot graph between t square and L. Now, what is the degree of t square? T square is represented along y-axis, L is represented along x-axis. So it is in the form of y is equal to mx. Y-axis is represented by t square and x-axis is represented by the length of the pendulum. So it is in the form of y equals to mx. So if you plot graph between t square and L, it should be a straight line passing through the origin. Just how we have discussed, isn't it? And what about the slope of this graph? So slope of this graph will give us, compare these two equations, it will give us 4 pi square by G. Or G would be given by 4 pi square multiplied by reciprocal of slope. So try to understand the significance of the graphical study. So by plotting the graph between t square and L, we will get a straight line, and the reciprocal of the slope of the above graph when multiplied by 4 pi square, that, students, will give us the value of acceleration due to gravity. Again I repeat, the reciprocal of the slope of this graph when multiplied by 4 pi square, that will give us the value of acceleration due to gravity at that particular place. So there lies the significance of the graphical study, right? So now let's consider the same case, and we are supposed to plot graph between t and L, not t square and L. We are supposed to plot graph between t and L, right? Earlier we have plotted graph between t square and L. Please try to understand the difference. Here we have plotted the graph between t square and L. It would be a straight line passing through the origin. Now if you want to plot graph between t and L, what's the degree of t? It is 2. So it should be a parabola. So it is in the standard equation of y square is equal to 4ax. Y is represented by time period, x is represented by length, isn't it? So it's in this form. 4a, which is constant, that is equal to 4 pi square by G. So what was the nature of the graph? It should be like this. It should be like this. So the graph would be in this case a parabola, like this. But since time period can't be negative, so you need not to plot the graph in this particular quadrant, right? So time can't be negative, so avoid this one. Avoid the plot of graph in this particular quadrant since time period can't be negative. So what I mean to say is that if the degree of the equation is 2, then it should be a parabola. That is what we have discussed now. Clear? So remember, students, it's a very, very important concept. Graph obtained between t square and L, that would be a straight line passing through the origin. But graph obtained between t and L, it satisfies the condition for a parabola. So it will be a parabola like this. Clear, students? So that was an example in which we can make use of our knowledge of the standard equations of various graphs in the interpretation of the graphs in physics, basically, right? So y square equals to 4ax, or x square is equal to 4ay, so, or y square is equal to minus 4ax, or x square is equal to minus 4ay. These all are the standard equations of a symmetric parabola, right? For asymmetric parabola, the standard equation is y is equal to ax plus bx square. That's the standard equation. So students, here again, it's a parabola. So what should be the degree of the equation? It should be 2. Degree of the equation for a parabola, it should be 2. Right? A and B are constants. Here A and B are constants. These are constants. The degree of the equation is 2 and A and B are constants. X, Y, obviously they are the variables. One is the dependent variable, the other one is the independent variable. So any equation which is in this form, and if you plot graph it in X and Y, it should be always a asymmetric parabola. Right? Let's consider an example. You are aware of second equation of motion, students. When a body is in uniformly accelerated motion, then as per the displacement time relationship, S is given by ut plus half at square. Now look, if displacement is represented along y-axis, right? Displacement is represented along y-axis, and time is represented along x-axis. Then what will be the nature of the graph? It will be a parabola, it will be a curved one. Either it will be along this direction or it can be along this direction. It won't be in both the quadrants because in this case it is asymmetric parabola. It will be only in the one quadrant. That is why it is known as asymmetric parabola. Right? It can be either like this. It will be the case of uniformly retarded motion, or it can be like this. It can be the case of uniformly accelerated motion. Right? In this case, acceleration is negative. In this case, acceleration will be positive constant value. So it depends whether the value of A or B is positive or negative. And accordingly, the parabola may be like this or it may be like this. It depends on the sign of A and B. Clear, students? So any equation which is in this form, the graph must be a asymmetric parabola. And this is the best example, second equation of motion. These are the two variables S and T, isn't it? Compare it with the standard equation. Here A is u and B is half A. These are the constants. So if you represent displacement along y-axis, time along x-axis, then the graph would be either like this or it will be like this. So that's the case of uniformly accelerated motion, where A will have constant positive value or A can have constant negative value. Right, students? Okay. Let's discuss some other cases as well. We are aware that gravitational force, it is given by G m1 m2 by r square. This is constant. So these are the two variables. It is inversely proportional to the square of the distance between the two bodies. So if a physical quantity varies inversely as the square of the other physical quantity, then the graph would be in this particular form. It will be like this. This is, suppose, r, distance, and this is force. Now look, for r equals to 0, F will be infinite. For r equals to infinity, F would be 0. So when we plot a graph, it won't meet either x-axis or y-axis. So it will be like this. This is the nature of the graph obtained. It will meet at infinity. So this represents F is proportional to 1 by r square. Clear, students? So the standard equation of this is y is equal to c divided by x square. So any equation which is in this form, the graph would be as shown in this particular diagram. Clear? Another case. For rectangular hyperbola, for y is proportional to 1 by x or y is equal to c by x, what will be the nature of the graph? It will be like this. This is x, this is y. Again, if you plot a graph, it should meet on both the axes at infinity. For x equals 0, y equals to infinity. And for x equals to infinity, y would be 0. So it is the case of a rectangular hyperbola. It will be like this. It should be like this. This is for y inversely proportional to x. So these are the various graphs which we will be extensively using in physics to show the graphical variation or to show the pictorial representation of the variation of one physical quantity with respect to the other physical quantity. Right, students? Okay, there are some other cases as well. Okay, students, we have discussed straight line, slope of a straight line, its importance, parabola, we have discussed both symmetric as well as asymmetric parabola. Now, let's discuss ellipse. So, ellipse is basically, suppose this is the origin, this is x-axis and this is y-axis. Ellipse is like this. This part, it is known as the major axis. It is represented by 2a. So, this is a and this will be a. A stands for semi-major axis. 2a is the convention which we make use for major axis. So, a would be the notation for semi-major axis. Similarly, this part, it is represented by 2b. And it is known as the minor axis. It is known as the minor axis, right? So, B, this will represent semi-minor axis. So, students, A and B, they are unequal in the case of an ellipse. One is greater than that of the other. The greater one, that's known as semi-major axis. The smaller one, that is known as the semi-minor axis, right? So, the standard equation of this particular graph is x square by a square plus y square by b square is equal to 1. So this is the standard equation of an ellipse. Right? Now one more thing, the last one. For a circle. Now imagine the case where a becomes equal to b. Then this ellipse will get converted into a circle. So let a equals to b is equal to r, say, and r be the radius. So the diagram would be like this. This is the origin and this should be the diagram in that case. So all the four parts would be equal, each being equal to r. So that it will be a circle. So what will be the standard equation? Let's substitute the value of a and b as r over here. So what we get is x square by r square plus y square by r square is equal to 1, which implies that x square plus y square is equal to r square. So this is the standard equation of a circle. Here r is the radius of the circle under consideration. So students, we have discussed the standard equation for a straight line, for a symmetric parabola, for an asymmetric parabola, the standard equation of rectangular hyperbola. We have discussed the standard equation of an ellipse, and finally we have discussed the standard equation of a circle. So I hope this session related to graph and the standard equations of various graphs must be very, very beneficial to you, right? And students, as I have always maintained, do try to utilize each and every second. Since you have opted for the science stream, so you need to show that dedication and hard work towards your studies, right? It is only through hard work that you can achieve success. So with that, I finished my lecture and will continue in the next session then. Till then, goodbye and do take very good care of yourself.